In this video, I'll be solving the fourth part of the first problem of UPSC Indian Forest Service 2025 Statistics Optional Paper 1. So let x1, x2 and so on xn be the random sample from exponential distribution with mean theta. So obtain the maximum likelihood estimator of theta. Also obtain the asymptotic distribution of the maximum likelihood estimator that you have obtained in 1 above. So that means like we are having like x1, x2 and so on xn. So they are following like i.i.d with the density. So density is like mean parameterization based on. So f of x by theta, f of x, the likelihood is 1 by theta into e to the power of minus x by theta when x is greater than or equal to 0 and theta is greater than 0. So if we find the likelihood here, so likelihood L of theta is product of this densities. So I is equals to 1 to n, 1 by theta into e to the power of minus xi by theta. So which is nothing but 1 by theta whole to the power of n into e to the power minus xi by theta. So log likelihood will be, so if we find the log likelihood, so log likelihood will just be minus n log theta minus summation I is equals to 1 to n xi by theta. So that means like if we find like dou L theta by dou theta, so which is minus n by theta plus summation I is equals to 1 to n xi by theta square is equals to 0. That means n by theta is summation I is equals to 1 to n xi by theta square. That means theta hat MLE is nothing but summation I is equals to 1 to n xi by n, which is nothing but x bar. So that means like MLE for sample mean, MLE is nothing but the sample mean. So theta hat MLE is nothing but x bar. So we can note that theta hat is unbiased. So expectation of x bar is theta, and we can also find the variance, which is theta square by n, right? So that's about the maximum likelihood estimator of theta. Now we need to find the asymptotic distribution of this maximum likelihood estimator. So that can be done by using like Fisher information. So if we compute the Fisher information per observation, like first we are having L1, the log likelihood, which is minus log theta minus x by theta. So dou square L1 theta by dou theta square is, so first like if I find the first derivative by dou theta, which is minus 1 by theta plus x by theta square. So this will be plus 1 by theta square minus 2x by theta cube. So that means like if I find like Fisher information for one observation, Fisher information from one observation, so that is nothing but I1 of theta, which is minus expectation of dou square L1 by dou theta square, which is minus of 1 by theta square minus 2 times expectation of x by theta cube, which is minus 1 by theta square plus 2 theta by theta cube, which is nothing but 1 by theta square. So that means that is for like one observation. So that means like for sample, the Fisher information will just be n by theta square because all are i.i.d random variables. So that means the standard, so we have by standard asymptotic MLE theory. So MLE theory, so this gives us square root of n into theta hat MLE minus theta converges in distribution to 0 comma I1 theta whole inverse. So that means this 0 comma, so this is theta square. So that is for root n. So theta hat MLE, so which is nothing but x bar in this case, minus theta in distribution will be normal 0 comma theta square. So that means theta hat MLE, which is nothing but x bar. This follows approximately normal theta comma theta square by n for large n value. So that is the asymptotic distribution of this x bar. So that's it for this video. We'll meet in the next